Hi guys, welcome back to the Seaborn, a statistical data visualization section. Let's talk about regression plots in this lecture. Seaborn have many built-in capabilities for regression plots. In this lecture, we will learn lmplot method. Later on in the machine learning sections, we will cover regression plots in details. Let's move on to the Jupyter Notebook and learn by doing. We are going to use tips dataset in this lecture. File, new notebook and Python 3. We need to import Seaborn and Matplotlib, and we are going to set Matplotlib inline as well so that we can see the plots within Jupyter Notebook. So import Seaborn as SNS, import matplotlib.pyplot as plt, and matplotlib in line, and let's run this cell. Let's load the tips dataset. Tips equal to sns dot, we can use load function, load dataset, and you can use tab to autocomplete, and tips. It's always good idea to check the head of your dataset. So tips dot head. So here we have once again total bill, tip, sex, smoker, day, time, and the size of the party. Let's add few cells here. So moving forward to lmplot. lmplot function allows us to display linear models with Seaborn. The method plot the data and regression model fits across a facet grid. This function actually combines regplot and facet grid. Let's call lmplot sns.lmplot and pass in x equal to, once again, total bill, y equal to, let's say we want tips, and our data is tips. Let's press Shift Tab to check its documentation string. So here we have range of parameters, x, y, data, hue. We can use column, rows, palette, and lots of other parameters we can play with. So at the moment we are passing x as total bill, y equal to tip, and data is tips. Let's run this cell here. So here we have, in this plot, we basically have a scatter plot with a linear fit to our data, which is on top of scatter plot. Let's copy this code and paste it here and pass in another parameter, which is hue. So we can pass in hue equal to sex and see how the things change with this parameter. Now you can notice that we have male and female separately with two different colors, green and blue. So in this plot, hue equal to sex conveniently split up the plots as well as color the hue based on the categorical features. So now we have two scatter plots and two linear fits with two different colors on top of each other. We observe that as far as total bill versus tip are concerned, the male and female have similar fit to the data. We can pass in the Matplotlib style parameters in these plots as well. For example, let's pass in the list of markers for male and female. For this, we need to copy this again, paste it here, and let's add another one marker here. So pass in the list, say we want circles and we want triangles. So let's run this, and here we have. So now we have circles for male and triangles for female. You don't need to worry about remembering these parameters. You can always go to the docstring and look at these parameters. And if you move down, you can read the explanation and how to use these parameters. Seaborn has a very good documentation on all of its features. So let's move on and see how can we change the marker size. So copy this one again, paste it here. Let's add few cells. So now we want to change the size of the marker. So we can pass in scatter kws equal to and dictionary where s equal to, say we want 100 and here. And if we run this cell, here we have changed the size of the marker. So let's pass in 200 and see the marker size is much bigger. Let's check for 500. So 100 is quite good actually for this plot. Let's check another feature actually and pass in here the palette. And we want, say, rainbow. And if we rerun, so we have different colors. We can check cool, warm, and so we have range of options in Seaborn to play with as far as palette is concerned. We can add more variable separation through columns and rows with the use of grid in Seaborn as well. So in this case, we just need to use column and row arguments in lmplot. So let's check sns dot lmplot, and if we shift tab, we have column and rows. Let's pass in x equal to total bill, y equal to tip, data is tips, and let's pass in col equal to sex. And if we run this cell, we have two separate columns for each sex, male and female. In the column 1, we are getting a plot for total bills versus tips for males only, and in the second column, total bill versus tips for females. We can pass in rows as well. So let's pass in row equal to, if we go back and check the data set, and here we have, let's pass in time here. So time. If we run this cell, now we have two rows. Let's fit this to the screen. So here we have column equal to sex, row equal to time. We have two times, which is lunch and dinner. So row 1 for lunch and row 2 for dinner. Whereas column equal to sex, one for male and the other for female. So let's use the hue parameter along with columns now. If we copy this code here, paste it here, and instead of column equal to sex, let's pass, say we want hue equal to sex instead of time. So now what we are asking, we want column for days and we want hue for sex. Let's run this cell. So now we have Thursday, Friday, Saturday, and Sunday. We have 4 columns, one for each day, and we have 2 different colors of plot on top of each other, one for male and one for female. We can play with palette here as well, so PALETTE, and say we want cool, warm, and if we run this thing, so we have a different color scheme here. We can pass in rainbow, and there are lots of options you can play with. So let's move on to another very important feature, which is aspect ratio and size. So we can adjust the size and aspect ratio in the lmplot as well. We need to pass in size and aspect parameter to do this thing. So sns dot lmplot, if we press shift tab once again, we see we have size and aspect. Default is 5 and default aspect is 1. Let's copy these lines of code, paste it here, and now pass in aspect equal to, say we want 0.5 and size equal to, say we want 10. And if we run this cell, so these plots are now with different aspect ratio and they are of different size. We can change size to, say, let's try to give a very small value, say 4 here. So here we have very small plots. It all depends what size of plot you want for your report or for your data presentation. So let's say we can change this aspect ratio to 0.7. And here we have different aspect ratio for our plots. We can change this to, say, 9. And here we have different size of our plots. So this was all about lmplot at the moment. Let's move on to the next lecture, where we are going to talk about another very important feature that is usually ignored by early stage data scientists, which is figure aesthetics. See you in the next lecture, where we are going to talk about figure aesthetic. Good luck.